Have you ever looked up at the night sky and wondered how we explore the vastness of space? The answer lies in the incredible power of rocket engines. These amazing machines use basic scientific principles to propel objects into space. Imagine yourself as an astronaut strapped into a rocket about to embark on a journey to the International Space Station. As the countdown reaches zero, you feel an incredible force pushing you upwards. Get ready to blast off on a journey into the world of rocket engines. We'll explore the basic science behind their operation and learn about some of the most famous rockets and their missions. To understand how a rocket engine works, we need to grasp a fundamental law of physics, Newton's third law of motion. This law states that for every action, there is an equal and opposite reaction. Think about what happens when you inflate a balloon and then let it go. The air rushes out, propelling the balloon in the opposite direction. Rocket engines work similarly. They burn fuel in a combustion chamber, creating hot, expanding gas. This gas is forced out of a nozzle at the bottom of the engine at incredibly high speeds. The reaction is a powerful force that pushes the rocket upwards, allowing it to overcome Earth's gravitational pull and soar into space. A rocket engine may seem complex, but it consists of a few key components that work together to produce thrust. Let's take a closer look at these essential parts. Where fuel and oxidizer mix and ignite, creating hot, expanding gas. Accelerates the hot gas, increasing the velocity of the exhaust, and store the fuel and oxidizer separately and pump them into the combustion chamber. Deliver the fuel and oxidizer to the combustion chamber at high pressures. Ensures the fuel and oxidizer are mixed properly for efficient combustion. These parts work in harmony to launch rockets and their payloads into space. Now that we know how rocket engines work, let's talk about the fuel that powers these incredible machines. Rocket fuel can be either solid or liquid, each with its own advantages and disadvantages. Solid rocket fuels are like giant firecrackers, burning consistently until all the fuel is consumed. Liquid rocket fuels offer greater control and efficiency, using separate tanks for fuel and oxidizer. One common type is a combination of liquid hydrogen and liquid oxygen, creating a powerful explosion in the combustion chamber. The choice of fuel depends on the mission requirements, with solid rockets often used as boosters and liquid rockets preferred for longer missions. The development of new and more efficient rocket fuels is an ongoing area of research. Throughout history, many incredible rockets have captured our imaginations and propelled us further into the cosmos. Let's take a look at some of these famous rockets and the missions they made possible. The most powerful rocket ever built, launching astronauts to the moon in the 1960s and 1970s. A marvel of engineering, launching like a rocket and landing like a glider, playing a crucial role in building the International Space Station. Developed by SpaceX, the most powerful operational rocket in the world, designed for missions to Mars and beyond. A European workhorse known for its reliability, launching satellites and spacecraft for over 2 decades. These rockets represent triumphs of engineering and human ingenuity. Each has pushed the boundaries of what's possible in space exploration. Rocket engines are the driving force behind our exploration of the universe. They have allowed us to land on the moon, explore planets with robotic probes, and send telescopes into space. As we look to the future, rockets will continue to play a vital role in our quest to understand our place in the universe. They will carry humans to Mars, enable us to mine resources from asteroids, and help us build a sustainable presence in space. Scientists and engineers are constantly working on new technologies to make space travel more efficient and accessible. The future of space exploration is full of exciting possibilities, driven by our insatiable curiosity and determination to reach for the stars.